Math! Hello everybody, this is Mr. Regener and this is the Aftermath. We are focused today on focus, and specifically we're looking here at focus week 25 for day 3. So you can follow along with your day 3 activity as we take a look at the answers together. So our first question is here. It says this is the net of a right rectangular prism. So we have the net drawn out for us on your page here. And this net, if you imagine that we could sort of cut this out of the page and then fold along all of these sort of bold colored lines, we would actually make like a box. This is something we're going to be getting into as we go throughout our school year. Haven't really gotten to it yet, so this is sort of brand new information that we haven't really learned. So we're learning about it here in focus. So this net, if you imagine like this would be one side of the rectangular prism. This might be another side, another side, another side, another side, another side. It's all going to be one 3D shape. Think of it like a cereal box or a shoe box or something like that. If you were to cut along all the lines and then fold it flat, this is what it might look like. So it says, what is the surface area in square feet of the prism? Now, it tells us in the key up here, which is fittingly named key because it's a key component to the question, that each line here is worth 2 feet. So this is 2 feet from here to here. This is 2 feet from here to here. We want to figure out the square footage of the prism altogether. There's a couple ways we can do this, and I think maybe the easiest way is to literally count the boxes. All right, so I'm just going to count them and actually number them here on the screen. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we have 10, 11, 12, 13, 14, 15. Then we have 16, 17, 18, 19. Then we have 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, and 38. So there are 38 total squares. Now, one thing that I would recommend is literally counting them out. Maybe you don't have to write the numbers in there, but at least like checking them. Because if we forget a square, that's a big deal. We would have a totally wrong answer. If each one of these, again, each square is a 2 by 2 square, then we have to think about the area of each square. Well, the area equals base times height. So the area would be equal to, in this case, 2 times 2. And 2 times 2 is 4. So the area of each one of these squares is 4 square feet. If I have 38 total squares, and each square is 4 squared feet, then I need to multiply 4 square feet by 38 total squares. So I'm going to take my total squares and multiply it by the square footage per square. Okay, so 38 times 4. Well, I can do the math here pretty easily. 4 times 8 is 32. 4 times 3 is 12, plus 3 is 15. I come up with 152 square feet. And if I look at my multiple choice options over here, I have letter C, 152 square feet. Letter C is my answer, and I figured that out by counting squares and then multiplying the total number of squares times the square footage of each square. Let's move on now to number 2. Number 2 says, what is the value of a squared divided by 4d times 3c minus 8b when a equals 10, b equals 7, c equals 4, and d equals 5? Wow, we've got some crazy stuff going on here, and it's a lot of substitution. So this one, remember, we want to just substitute. So for our purposes here in the video, I'm going to take this equation here, or this expression really, and then plug in the numbers, the values that I see. So I'm going to write it out first just so we can all see it very clearly. Okay, so there they all are. There's all my numbers, right? Everything that's in that expression. Now it says a equals 10. So I'm going to take out a and put in 10. That's going to be 10 squared. It says that d is equal to 5. So remember, this is 4 times d. So it's going to be 4 times 5. And then I have C. C is equal to 4. So I'm going to multiply 3 times 4. And then B is equal to 7. So that's 8 times 7. Now this looks like a lot of work, and it, to be honest, kind of is, I suppose. But we need to just follow our order of operations, which we remember is PEMDAS. So if I'm following the order of operations, I start with parentheses. Parentheses are here, so 4 times 5. I'm going to rewrite this each and every time, just so we can make that little Dorito chip as it completes all the way down. So I have 4 squared divided by 4 times 5, which is 20, times 3 times 4 minus 8 times 7. Okay, next up in my order of operations, the E stands for exponent. So I'm going to take my exponent, 10 squared. That means 10 times 10, you may remember, and 10 times 10 is 100. So let's go ahead and do that. I'm going to write 100 divided by 20 times 3 times 4 minus 8 times 7. Next up in the order of operations is the multiplication and division step. Remember, I read it like a book, so I read from left to right across the page. That means if I have a division problem first, I do that first. And I just happen to have that division problem. 100 divided by 20. You might know that 20 goes into 100 5 times. So I don't think the math is going to be too hard here. It's really just a matter of following that order of operations after you substitute correctly so that we get the right answer in the end. Next, I have multiplication, 5 times 3. So 5 times 3 is 15. Next, I have another multiplication, 15 times 4. Well, 15 times 4 is going to be 60. So you may need to do that math off to the side, and that's OK if you do. Or maybe you can do that quickly in your mind. I'm going to extend my page a little bit more. Next, I have subtraction and multiplication. I want to do the multiplication first, because remember, it's order of operations after all, and multiplication comes before subtraction. So I have 60 minus 8 times 7, which is 56. And now I can do that subtraction problem. 60 minus 56 gives me 4. So I get that nice Dorito chip there. I know I've extended the page quite a bit there to see it all. But we started off again by just substituting our values and then just going through PEMDAS, order of operations. This one has a lot of work to it. But again, I don't think it's difficult work. It's just a matter of keeping it consistent with the order of operations. Let's move on to number 3. Number 3 says Anita brings 4 dolls to her grandma's house. These dolls represent 10% of Anita's doll collection, as shown in the diagram. What is the total number of dolls in Anita's doll collection? Well, if we take a look, we've got this awesome diagram, so we want to use this, right? This is 0% of her dolls, which oddly enough is 0 dolls. That makes sense. 0% of the collection equals 0. 100% is what we're looking for. That's the total number in the collection altogether. We know that 10% of the collection is 4 dolls. So a lot of ways that we can kind of think about this one as well. And I'm going to go ahead and use the chart, use the graph that they give me to kind of make sense of this all. So if this number right here, from here to here, is 4 dolls, it stands to reason that from here to here is also 4 dolls. And then every one of these 10% would be 4 more dolls added to her collection, right? So 10% of the collection is 4. 100% would be 4 times 10. Or if I wanted to add it up, 4 plus 4 plus 4 plus 4, I could do that as well. But in the end, I'm going to figure out that there are 4 dolls for every 10%, and there's 10 10% in 100%, so it's 4 times 10, which equals 40 dolls. Now, that's a pretty easy one, I think, as you look at it. Hopefully, you're thinking that it's pretty easy. Again, use this chart up here to help you figure that out, because that just makes the whole thing a much, much easier problem. Let's move on to number 4. Number 4 says point Q is plotted on the coordinate plane. Which statements are true based on the graph? Well, first, I want to point out that we are looking again at a coordinate plane. We saw this last week on Focus as well. So remember that we always start at our origin at 0, 0, right here in the middle where x and y come together. And then from there, it's kind of like an elevator. Like if you get on an elevator, you have to walk on the elevator first side to side. Then you can go down or up, right? So if we're starting the origin, we want to follow the plot here to the left first, then up. We're going to the left to -3. I don't know if you can see it so much on the video, but you can see it on your own paper, I'm sure. -3 is right here. We go up 2 spaces. So point Q right here is -3, 2. Those would be the coordinates for point Q, or the ordered pair, the x and the y values. That's going to help me a little bit in kind of getting this started. We're going to come across some other things here, which I'm going to explain in just a moment as well. But look at letter A. Letter A says Q is the point 2, -3. Well, 2, -3 would be over here, +2, and then down 3, that would be like right here. That is not the same point. Obviously, they're in different spots. So letter A is wrong. Letter B, Q is the point -3, -2. Well, this is -3, and then this is -2. This is not point Q. That's point Q. This is not. So it can't be letter B. Now we get into this idea of reflection. And when you look in a mirror, you're seeing a reflection, right? If you get really close to a mirror, right, you can see that you are super close. And I probably just frightened you. I'm sorry. But when you get really far away, you're really far away. The same is true with a reflection, right? So if you look at point Q, we can reflect point Q across the y-axis. Remember, this is our y-axis there. If I reflect it across, it's going to be the same distance away from that y as it is on this side as it would be on that side. It's a complete reflection, like it's looking in a mirror. So if I look at this, it would stay on the same x-axis if I reflect it across, but it would not be on the same y-axis. It's going to flip. It's kind of like if I take this whole thing, and I'm really strong, and I'm sure I could do this, but I don't want to. If I take this whole smartboard and I just bend it right here at the y-axis, right, it's going to leave a little dot over here, right? And if we had our paper, and I'd encourage you to do this on your own paper if you'd like, you can fold your paper on that y-axis and kind of see where that Q would land. But I can predict where that's going to be because, look, it's 1, 2, 3 spaces from y. So I just need to go 1, 2, 3 spaces from y on the other side. And this would be the reflection of Q across the y-axis. Letter C is asking me if Q is reflected across the y-axis, its coordinates would be 3, 2. That's +3, +2. Let's take a look. So I go 1, 2, 3, 1, 2. This would be 3, 2. So letter C is correct, because if I reflect Q over the y-axis, it would be 3, 2. For letter D, it says if Q is reflected across the x-axis. Ooh, big change of plans here. Now I'm going to fold my paper or fold my smartboard over across the x-axis. And if I did that, I would still be on the same y-axis, but my x-axis would change, right? So the y is still the same. I'm still at -3. But here I notice I'm 1, 2 away from x. So I'm going to go 1, 2 away from x. And right here at this point, which is -3, -2, would be the reflection of Q over the x-axis. So if Q is reflected across the x-axis, its coordinates would be -3, -2, and that indeed is correct. So I'm going to go ahead and circle that. Finally, letter E, it says if Q is moved to the right 3 units and up 1 unit, its coordinates would be 0, 3. Well, let's take a look at it. So I'm going to use a different color here. You can kind of do this on your paper as well if you need to. But here's Q. It says if I move it to the right 3 units, so 1, 2, 3. Boom, there it is. And then it's going to move up 1 unit. So boom, up right here. That coordinate right there is going to be 0 on the x. I'm not going to the right or left. I'm just staying right in the middle, 0. And then I went up 1, 2, 3. So 0, 3 is this point right here. It says if I did that, its coordinates would be 0, 3, and that is correct. So in this one, we have A and B that are both incorrect, and C, D, and E all work. They are all correct. That's our focus for this week. Obviously, we've got our quiz coming up, so we want to make sure you're preparing. This video may help you prepare. So good luck on your focus quiz, and have a great day.
Math! Aftermath, it's the aftermath. Aftermath, it's the aftermath. Math class is fun, but when it's done, stay in the zone. On your own, it's math review, made just for you. Take a video wherever you go. Aftermath, it's the aftermath. Aftermath, it's the aftermath. Oh yeah.